Okay, so that video introduced the idea of brain waves. These are the electrical signals in our brain that are actually measurable via these electrodes that are placed on your scalp. This is a method called EEG. You'll see here's a picture of me actually wearing an EEG cap I did as a research experiment in undergrad. It feels like an alien, I'm gonna tell you, but it's really cool. So if you have the chance to volunteer in an EEG study after COVID, when it's safe, highly recommend. But the cool thing about this is that you have electrodes placed all around your scalp. And each electrode is able to record the electrical activity from a different brain region. So this is what you see output here. So each kind of row is a different brain region, a different electrode. And you can kind of see it just oscillating up and down. So different things are happening as that brain region is awake or not. Or active or not is probably the better term. So these brain waves are indicators of overall kind of brain activity. The faster the wave, the more active the brain is. So if you remember kind of waves we talked about in the last section on like vision. So if a wave is really fast, if it's really quick up and down, it has a very short wavelength, then that means that brain region is really active. Whereas if it's really slow and low, that means that that brain area is less active. It's calmer. So scientists are able to use these brain waves to determine how awake or asleep, what stage of sleep someone is in. So let's talk about waves. These are the 5 main waves that are referenced in your book and that are typically associated with sleep. So looking at waves again, we know that they kind of vary in multiple components. They vary in frequency, which is the number of cycles per second. So basically how often it goes up and down returns to the same point in 1 second. So frequency is measured in hertz. So in this case, what we're organized in here from top to bottom is highest frequency, things over 30 hertz, to all the way down to lowest frequency. This is only 1 hertz, and you can see that it doesn't return back to normal very quickly. So frequency is the main component. We talked about wavelength too, which is how wide each of those peaks and troughs are. So as we go from the highest frequency, the lowest wavelength here, we have gamma waves. Gamma waves are mostly active when your brain is highly paying attention to things. So it's a lot of active brain activity. It's when you are really paying attention to external sensory input. A little bit lower than that is a beta wave. So beta waves are active when you're alert, when you're awake, not necessarily focused on some hard cognitive task, but just generally doing your life, just being awake. Then we move down to alpha waves. So alpha waves are the waves that when you first, sit down in your cozy chair after a long day and you start to slowly kind of drift off. That's alpha waves. You're still awake, but you're so relaxed that you're just in this like nice kind of tingly state. Then as you move a little bit lower and you're starting to very lightly actually fall asleep, this is a theta wave. So this is when someone can still wake you up, but you're technically asleep. And then as we get lower and lower down into the deepest amount of sleep, our brain is fully slowed down. So this is called a delta wave. Now, if you want a little mnemonic for how to memorize the order of these frequencies, since it's not in alphabetical order, I made up this little analogy. So if you remember that grandma bakes all the desserts, it'll help you remember the order from gamma, beta, alpha, theta, delta, from fastest to slowest waves. Grandma bakes all the desserts. Okay, so now that we've kind of briefly introduced each of the waves, I want you to make a prediction. So on the left-hand side, we have the different stages of sleep that we talked about earlier, from being fully awake to having REM sleep, where it resembles waking, but you're asleep. And then the 4 stages of non-REM sleep. And then here we have the 5 different brain waves that we just talked about. I want you to make a prediction. Which brain waves do you think are active during each of these stages? So looking at the descriptions, which do you think matches?